Chandy.
Hi, Sarah. Thanks a lot for having me on this session. I really appreciate that. So first off, let me go ahead and share my screen. Can you see it now?
Yeah.
Just going into presentation mode. Give me a minute. Okay. All right. So I'm Chandy, and I'm out of Boulder in Colorado with Inteliquent, as Sarah just said, with 911 and emergency services. Our tagline is modernizing emergency communications. So we are one of the newer, and you will see, I'll share a timeline here, which shows you what's been going on in the 911 world. And what I'd like to share is, one of the biggest things in 911 that we hear a lot is, how is it that Uber can find me, but 911 can't? And I will consider it a success criteria of my talk if I can avoid that question during Q&A, because hopefully this session will answer that question. 911 truly is a very complicated topic. And as you know, here in the United States, this has been undergoing enhancements and new features, etc., over several years. So before I get into the details of 911, I just did want to share a little bit about Inteliquent. I'm not sure how many people are familiar with Inteliquent, so I just wanted to give a quick background. Inteliquent, we enable communications. We offer voice messaging and 911 solutions, and we're trusted by the industry's largest mobile cable, wireline, and communication service providers. I'm not going to go through all these icons, but we have some of the largest names as our customers across the board. And at the bottom, as you can see, top 5 service communication service providers, top 7 CLECs, top 6 wireless carriers, top 10 wireline companies, and the top 8 cable companies. So we're really big, one of the largest tier 1 providers, communications providers in the United States. Okay, here are some of our products. We specialize in inbound voice, outbound voice, toll-free, enhanced services, which includes UCaaS solutions, messaging, as well as 911. And for 911, we have several different products which we categorize into 3 primary buckets. One is the 911 gateway, which is the actual network solution which transports and delivers 911 calls across the country, across North America. And because we are a network company, this is our flagship product, whether the state or county is in the traditional E911 setup or in a next generation 911 setup. So we have very in-depth expertise in this. The second one is the nomadic location, which is typically called in the industry as the VPC, the VoIP Positioning Center. And so for any VoIP solution providers, this is our 911 solution. And then the third one is the NG911 aggregation service, and NG911 EZINet. Basically, that is the solution for governments. So this is basically as governments, counties, states move to next generation solutions, we offer products to the government, to the state or the county, which accept and aggregate the 911 calls for them and deliver them to the NGCS cores. So that, in a nutshell, is a little bit of the background on Inteliquent. With that, I want to get started on 911, and hopefully this will be some kind of a primer, given that I'm not too sure how familiar this audience is with 911. I'll give you a little, and these are very high-level milestones. So back in 1968, or more than 50 years ago, the first 911 call was made in Haleyville, Alabama. So that is when the 911 infrastructure was all being put into place. This is when the U.S. truly got into, the 911 three-digit solutions, and how, and then the rest of it will show how it's evolved and why 911 is so complicated. Then about in 1988, so remember, from 68 onwards, for a long time, it was all just wireline solutions, physical, end-to-end connectivity. And so basically all we needed was locations of all these phone systems in residences and businesses, et cetera, et cetera. And then as we went along, when the cellular companies came into, wireless started coming on into the industry, and there were certain regulations that were then placed. In 1998, phase 1 wireless was first declared, and that was basically that when a call is made from a wireless handset, then we needed to provide the PSAP, which is the public safety answering point. So that's where your calls go to, the 911 calls go to something known as the PSAP. Typically, they're in sheriff's departments somewhere in the county or the city or the state. Basically, phase 1 called for the caller telephone number as well as the location of the cell site where that call originated. So that still is a pretty decent, large footprint. And so they would just call back that number and have a general idea of what cell site the location was of the call that came through. Then in 2001, there was phase 2 wireless. And what that meant was the solutions that were there had to provide the PSAP with the latitude and longitude of the caller within 50 to 300 meters. So that was the first, much more of the location accuracy aspect, where they said, okay, now you need to bring down that location instead of just the cell site, which is a pretty large footprint, to within 50 to 300 meters. So that was when the wireless industry was going through a lot of change, and when more location accuracy was required. Then in 2003, some of the requirements NENA started driving the need for a next generation 911. Remember, this now had been in place from 1968 through 2003 to the early 2000s. And a lot of technology had changed, and think about it, wireless cell phones itself, videos, text messages, all kinds of things were coming up, which we needed to get incorporated into our 911 solutions. So NENA started driving a lot of activities in 2003 for defining and designing next-gen 911, just to enable voice, video, text, data, auxiliary data, etc. So a much more sophisticated solution. So those definitions began. Also in about 2003, the FCC started imposing rules for bounce back of 911 text, because what was happening was people were texting to 911, but there was no requirement that if the public safety answering point could not support text to 911, they weren't being notified. So here the caller would wait for police to show, or emergency services to show, and there was nothing because the PSAP did not have that, did not receive that call. So then there was a bounce back requirement, which was very important. And for the speaking impaired, hearing impaired communities, this was very critical. And so then the next step was in 2005, VoIP solutions started becoming very prevalent. And there were rules then for interconnected VoIP. So again, you need to allow for 911 calls over your VoIP lines. You need to allow for, provide the location, etc. So that was 2005. Then there's this whole concept, I'm sure all of you, after 9/11, the New York City incident, basically the concept of a national public safety broadband network came up. To be for the first responders to be a dedicated network so that there's always access, because during 9/11 there were a lot of learnings out of that, and whether all the right facilities were available and the resources were available to the people who were on the ground. So this was, and in 2017, so all this conversation started in 2011, and this went on for quite some time. And in 2017, AT&T was awarded FirstNet contract to start building the NPSBN. Then in 2018, there was some additional regulations that was enacted by the FCC, and that's Kerry's Law and Ray-Bonds Act. This related to, a lot of things happen out of necessity and out of incidents that occur in true life. And in this case, a lady by the name of Kerry was in a hotel room, and she basically, she was killed in the room while her child tried to call 911, but because you have to press a 9 before you get out of a hotel room, and then press 911. The child knew to press 911, but did not know they had to press a 9. So some rules were enacted saying all these behind PBX, and it's not just hotel rooms, I'm talking about, enterprise, etc. So anything that's behind a PBX would have to bypass the 9 and then 911. 911 should be dialable from anywhere. And that anyone who dials 911 from any place behind a PBX, that notification should go to some predefined, pre-configured party. So people would know there's a 911 call going on and see what they can do for some quick local support. And similarly for Ray-Bonds Act, which is actually the auxiliary to Kerry's Law, it basically says the location has to be there in a much more accurate format, because what was happening was a lot of the location was based off of the hotel address or the enterprise corporate business address, and did not go to the detail of where that 911 call truly originated. So all these things, as you can see, the reason I'm sharing the slide is the landscape has been changing. So 911 has become fairly complicated. And as you know, with NG 911, things are going to get more and more advanced as technology keeps improving. So this kind of will also share what we're seeing with technology. What are the different use cases? How did we start? It started with something really simple, which was the landline, right? Then, like I said, we talked about the mobile phones going through the CMRS system, the carrier mobile services. And then from there, let's move on. You have the MLTS, the PBXs. And then now when we're talking about the bottom two layers, which are exploding, as most of you know, IoT, telematics, mobile over-the-top solutions. So these are all next generation solutions that require 911, and there are already some basic structures. So for example, today, if you have an IoT device that is requesting that you need some help, emergency help, typically they go to some kind of a call center. And from the call center, they can choose to patch in the 911, the PSAPs. So, and if you really think about the future, the possibilities are endless. There are all kinds of potential things, like whether you talk about fire alarms, smoke alarms, Alexa devices, name it, everything, your car making calls based on an accident. And so basically, as we get better, more and more sophisticated technologically, these solutions, 911 has to keep up and make sure that we can support a lot of these solutions. But the challenge in this case is the fact that if you think about a PSAP, last thing, and I know most of us have been through this, I've been on vacation and then I'll suddenly get this, when I come back from vacation, I'll have these notes on my door saying, well, you tripped the burglar alarm and this is your first notice, you shouldn't, it was a fake alarm. And so do we want all these devices to be sending alarms to the public safety answering points without some form of scrutiny, whether it's a call center, whether it's some kind of AI solution, etc. So there's this whole world that's going to come up that is already being talked about. We have standards committees and boards that are discussing all these different potential possibilities. Then you have at the bottom that I've written, which basically utilizes some of these, is all the safe city, smart city solutions. Cities want to move to a much more smart solution. So if you think about traffic lights and cameras detecting accidents, etc., there's a lot of things that a smart city, and there are already certain sorts capabilities that are being generated and published in smart ads. In fact, Denver is one of them that there are quite a few smart city solutions there. And then, of course, like I said, enterprise 911 solutions, we can get really sophisticated, whether it's a campus, a university, a hotel, whatever it is, you can define much more in-depth emergency solutions. So this is the landscape that we're talking about. So how do we now then govern this kind of a landscape? Because in the end, it's the public safety answering points that are accountable to service these requests. Now let's come to public safety entities. So there are about 250 million calls to 911 annually. And all this is supported through the 911 fees that are collected by states and signed back into the into building better system solutions, etc., and resources. So and this is just a very typical high-level diagram which shows how states are set up. So let's say there's a state-level 911 program. So here's a state. This looks a little bit like Colorado, my state. It's a state level program, and there's a 911 executive director or a coordinator who provides support to the various 911 authorities within that state. So let's say this state has two authorities, 911 Authority A and 911 Authority B. And so they basically are responsible for either, their county, their region, etc. And they provide the 911 operation for that region. And then the PSAPs are within each one of these authorities, they would have PSAPs. So let's say there are two PSAPs in 911 Authority A, and there are 5 PSAPs in Authority B, based on how large those counties are, etc. And so then that's where those calls are received and dispatched based on the caller need and the location. And then behind these PSAPs are what's known as ESNs. And ESN is, interestingly, a combination of numbers, it's a combination of fire, police, and ambulance that get assigned a specific number. So let's say this 123 ESN would have maybe the Louisville Police Station, the Superior Fire Station, and a certain medical response center. So it actually refers to a unique combination of the three. And then there's always something known as a default ESN, which basically, if you don't have all the relevant information into the PSAP, there's always a default. So let's say in this case, this one, that will pick up the calls for that region, that authority, or that area for that PSAP. If there are calls coming in, then this basically ESN will pick up that call due to any missing information. So that gives you an idea of how this is set up. Now let's move on to how is all this governed from a I'm going to talk about all the different bodies that are involved in making the U.S. a safe and secure place, and some of the requirements that flow down. So I remember in my last job, I used to be on monthly calls with the Department of Homeland Security, and we would listen. It was obviously listen only. We would listen to what are the new, they would have these bulletins and they would share it with all the what is known as critical infrastructure solution providers, and we would hear and understand what their key focus is and what their, what we should be thinking about in our solutions. So basically, the DHS provides oversight for mission critical infrastructure. What is mission critical? What are the key things that need to be up and available during emergency incidents? And as you can see, under the Department of Homeland Security, there is an organization here called the Cybersecurity and Infrastructure Security Agency, the CISA. CISA ensures that public safety and national security and emergency preparedness communities can seamlessly and securely communicate during steady state and during emergency operations to keep America safe, secure, and resilient. So it starts right from the top where we have, here's how we need to operate as a country. Here are all the different departments, organizations, resources, capabilities that need to be available, and how do they cross-communicate, etc. So it is that high-level oversight. And then CISA's role in emergency communications, if you look at the bottom, and basically CISA enhances public safety interoperable communications at all levels of government and conducts extensive nationwide outreach to support and promote the ability of emergency response providers and relevant government officials to communicate in the event of natural disasters, acts of terrorism, and other hazards. So CISA coordinates across several different bodies to get this, to ensure that we are always safe. Now let's bring in, how does the FCC play in 911? And one of the key bodies that ensures that 911 operates smoothly is FCC sets rules, working with public safety agencies, carriers, manufacturers, and other providers to ensure effective emergency response is a critical element of the 911 environment. And as we speak, the FCC has been accelerating the need to transition E911 to NG911 to enable all the new technologies. So that's one of their goals. Location accuracy is another goal. So there's several different things that FCC has priorities, and they share that with us. So let's start with, the FCC has several regulations, the phase 1, phase 2 that I just talked about for wireless, the VoIP requirements, Kerry's law, et cetera. They pass all these regulations and we adhere to them as service providers. And then there's the FCC reliability order, which basically Title 47 is key in this situation. There's Part 4, there's Part 12. Part 12 is huge for people like us, like Inteliquent, because it's the reliability of our nationwide 911 network and requires diverse 911 circuits, backup powered, and the diverse aggregation monitoring points, etc. So they called out how, some general basic guidelines of how this needs to be managed. And then Part 4 of it is basically, if you do have a problem, what do? You have to provide all kinds of reporting and notification. And there are, again, very strong requirements as to, if you think you could have potentially impacted 900,000 minutes, user minutes, or your outage lasts 30 minutes or more, et cetera, they have very clear requirements as to at what point you have to notify. And then there's 2 big notification requirements. One is to the PSAPs itself, because you want to give them the ability to put in all their alternate, practices in place. NORS reporting, which is basically going back to the FCC, to a repository to say, this is what happened and this was how we fixed it and this is how we're going to improve, etc. So this basically all the tracking and reporting requirements. And then, of course, the FCC does enforce some penalties if there are, if there are outages, and especially if the notification is not being done appropriately, etc. And then you have to enact a consent decree and, do your lessons learned and get, in line with the requirements, etc. So that's talking about the FCC. Now, FCC has an organization known as the Public Safety and Homeland Security Bureau, PSHSB. So now that's this organization. And basically the PSHSB promotes the public's access to reliable 911 emergency alerting and first responder communications. And they also develop and implement policies to ensure that the first responders and the American public have access to reliable communications, to make sure that everybody's getting whatever communications based on, what's going on, incidents that are occurring, etc. And of course, they collaborate with federal government partners responsible for protecting the nation's communications infrastructure. So I know we basically meet with the PSHSB, FCC, etc., as and when it's required. So these are all key organizations in the 911 landscape. Moving on. One of the organizations that we work very closely with, and which is the leader of 911 in North America, and is NENA, National Emergency Numbering Association. So basically, this is the 911 Association improves 911 through research, standards development, training, education, outreach, and advocacy. So basically, they are the key day-to-day, they live, breathe 911 and define standards that we all adhere to, and they bring together all these standards bodies from across private and public sectors to build it correctly and define it correctly. So they have about 15,000 members in 48 chapters across the US. They define all those standards, and those standards are then published under the auspices of NENA. There are other bodies, of course, that do define standards like ATA CISA and IETF, etc. And the NENA vision is basically a public made safer and more secure through universally available state-of-the-art 911 systems and trained 911 professionals. So they provide all kinds of training, conferences, etc. And it's like the master body of 911. Okay. So the next thing I want to touch upon is public safety grade infrastructure. So this is something that most of us in 911 abide by when we build anything, any solutions, whether it's soft applications, whether it is networks, whether it's government solutions or industry OSP solutions, we talk about public safety grade infrastructure. So what is public safety grade? So the National Public Safety Telecommunications Council is the one that defined what is public. It's a thick document with several sections that address all the categories that you see below. And of course, I'm not going to go through every one of them. I'll talk about a couple of them that are very critical to us. So let me start with, what is public safety grade? Public safety grade is a term that refers to the expectation of emergency service providers, response providers, that their equipment and systems will remain operational during and immediately following a major natural or man-made disaster on a local, regional, and nationwide basis by providing the network hardening or network sustainability. And, you know, basically bottom line is being able to reroute in the event of any situation or incident, and to be able to have other, whether it's a PSAP, whether it's a network, or an application, to be able to fail over to something completely in a different physical area. So the best practice guidelines provided in the for example, the NPSBN, which is the FirstNet solution for public safety broadband network. So there's lots of things that, and needless to say, these best practices are for everybody, and it's not just for FirstNet or anything. So we adhere to a lot of these, like most of anybody who's in 911. So I'll touch upon a couple of these things. So for example, geographic specific events. So geo-redundancy is absolutely critical for all our solutions. We have to have solutions in completely different geographical areas of the country, so that it's, you know, one area is hit by, whether it's a hurricane or a storm or whatever, and then something that the other region of the country can pick up. The other one that's critical is reliability and resiliency. And the way we address that is that it's through carrier diversity. Very often people talk about circuit diversity, that you have backup circuits, but you have to take that to, you know, one step further, which is carrier diversity. You don't want to use the same carrier for your primary and your backup circuits, because very often they terminate, etc., at a common point if it's within the same carrier, and they could be common points of failure. So and then there's a bunch of other things, like I said, you know, power, site hardening, installation of the actual data centers, operations, maintenance. These are all a lot of the physical redundancy and infrastructure needs. And then, of course, within an application on the right-hand side, basically how you're building your applications itself with the kind of scalability and adaptability and security. So one of the biggest things is, of course, security and information assurance. How do you ensure that you have that you have the right tools, etc., in place? First, to make sure that you're thwarting any kind of attacks, and B, to ensure that if there is an incident, and how do you overcome those? So very critical security requirements behind public safety grade. So then let me just kind of wrapping up a lot of these different thoughts is security. So cybersecurity is key. You want to make sure everything's being built with the right segregation of your networks. We always have, we design our solutions in a way that the kind of firewalls and everything that we set up, the demarcs, the different segments of our network, everything is very clearly designed and implemented to meet some of the key requirements. And we are, you know, as we speak, and there are lots of ISO 27001 practices that we have to follow. And you know, another small piece of this is I had to undergo CISA certification to support, to be able to, understand a lot of those key requirements and ensure that we were delivering solutions to a lot of these requirements. And some of the things that we deliver, that as a 911 organization, we have to be on top of is things like annual report of internal controls. What are we doing regular risk assessment? Are we mitigating our risks? What are the compensating controls if there are certain risks that are still open? What our access control mechanisms are? And one of the biggest things that I personally have a lot of passion for is change control. This is 911, you don't touch it. And as you know, we still are very nimble. As you know, as I said in slide 1, our tagline is modernizing emergency communications. So we deliver solutions for our customers very quickly. We have very fast turnaround in releases. Our infrastructure is all, advanced infrastructure, the servers, the hardware, the networks, the etc. So basically, then how do you marry these two worlds, right? Change control says you can't change without having all the right practices in place. And yet you want to keep bringing in new technologies and staying relevant and keep improving and enhancing and meeting your new customer needs on a regular basis. So marrying these two worlds is critical. And again, like I said, that is my passion. And we ensure that we are bringing in those change control practices from the old world, from the more stable world, into this new fast-changing paced world. And it's been working really well, knock on wood. And so basically, this is a very critical aspect of my job for sure. And then, of course, asset management, the physical environment management. How do you minimize your vulnerabilities via pen testing, making sure your third-party suppliers are compliant with the practices that you have. And then, of course, all the audits that you put in place, the kind of training that we have to provide to all our internal teams. 911 is like I always say, is a completely different animal, just like Frontier calls their planes all different animals. 911 is a very different animal, and I want to make sure that while our company is built on top of the telecom network and backbone, we still have a whole 911 division that focuses on nothing but all the requirements that we need to meet in 911. So the audits, the training, and of course the last one, which is BCDR. We have to make sure that at any point in time we have to be able to provide the business continuity and disaster recovery. I'm not going to go through the right-hand side, which are all the different control sets and how do you ensure that you have the different cybersecurity practices, policies in place, and getting compliant with these controls or putting in compensating controls. So, and then of course, this is, obviously you can do as much as you can from hardening what you create and build. The other side of this is there's always somebody who is out there who's smarter, who is, whether I call it smarter, but basically who can break into anything and try to destroy what you have. And if there's a threat, and if something happens, how do you react to it? And so we have very strong incident management practices, and we bring in these teams, and we have, again, all the failover, all the things that we talked about in the previous slides, where you can reroute, get our entire network backbone, which is what Inteliquent is known for. We have enough redundancy across the country to be able to fail over, turn around, and reroute our solutions, the network packets, and making sure that call completes. So that, in a nutshell, is emergency services and 911 landscape. So what I'd like to do is, hopefully that gives you some kind of insight into how complicated this is, and why this 911 is something that is it's a source of passion, and it is something that you have to be very involved in ensuring you stay with the current practices, the industry. So there's all kinds of pressures, all the way coming from new technologies to the stable. Here's a very fast-moving new technology world with all the IoT devices, and then you've got a very stable public safety world, which you don't want to keep changing their practices. They go through a lot of training and facilitation, and their solutions on their desktops, their CPEs that have to change if something on this side changes. So and we're in the middle, driving all these solutions from a very fast world to a very stable world. And how do we then marry the two worlds? So it's a complicated and very exciting world in 911. So with that, I'd like to open it up. If you have any questions. So I'm going to kind of close the document. Stop share here.